process of the microbes breaking that down fresh provided a huge benefit. We don't we don't see that same kind of benefit out of using like a manure or something else that's been composted and put back in the soil. Not that it's not beneficial, but it's a difference between that versus a green manure crop. So,
Isn't it interesting, that term, green manure?
yeah.
And what you're saying is they saw a benefit, they saw an effect.
And that was practiced before we had commercial fertilizers.
Mm-hmm.
Yeah.
That was back then over in Europe. I mean, a lot of they either had crop residues or they brought in, seaweed and kelp and things in the coastal areas. They would enrich their farm fields with that. So in a way, we're mimicking some of that's lost. I mean, especially when we take an integrated approach where we are applying enhanced fertilizers, but yet we're making better use of the natural processes as well.
So with that, when you talk on the environment and on compacted soils, which seems to be a big problem, it's causing a lot of runoff. Let's talk a little bit about that and where we're going. What do you think?
Well, yeah. So certainly, I mean that's one of the big stories in talking about nutrient cycling, organic matter cycling, crop residue cycling. We can create what's called extracellular plasmic substances. That's a fancy term for mucilage or kind of slime, if you want to think of it that way. That bacterial slime, if it's produced, with good anaerobic bacteria, really increases the aggregate stability of soils. So it helps the soils aggregate better together. Now, I mean, that can go awry, and especially in anaerobic soils, that bacterial slime from anaerobic organisms can actually biofoul and plug up the system. But we're not talking about that. We're talking about cultivated soils, aerobic soils, a very beneficial process. So if we're affecting that process, we're both improving the efficiency and improving the reactivity of the products of organic decomposition, as well as that extra cellular plasma substances. I mean, it's just a win-win situation.
I think so. Hey, one other question I want to throw out to you in particular, Michael, but anyone else weigh in? Because a lot of what we're talking about, we're a soil amendment, and I think we've spoken about that this team has really spent most of their time with commercial agriculture, but now we've come out with some products on turfs and trees and horticulture and racetracks and stuff. Are they really, we're dealing with soil, are they all the same, and do you think we have efficacy on all of those?
Yes. The bottom line is yes, because we're even in the cases where we're not trying to drive yield, we're still driving plant health. So in an application like a landscape application, plant health is important. If nothing else, ornamental function as well as trees function for shade and so forth. In a turf application, turf is not just there to make things green and beautiful. It's got a very utilitarian function. It has to be tough and take a lot of abuse on athletic fields, and especially when we move to horse tracks. The turf takes a lot of abuse, and if we can help that turf be stronger and healthier, then absolutely it benefits. And the other thing is in the application, now this happens in natural soils too, and even especially out west, but where we have manufactured soils all over the country, they come from below the surface, and we have a lot of issue with carbonates. And so the carbonates will we bring it to the surface, and they start to react a little bit, and they cement up and create clotting, they create crusting, they plug up the soil pores, and they can be quite a problem, especially when it's combined with a little bit of sodium in your irrigated soils. And so we can positively affect that, because acid directly reacts with carbonates.
So it's all soil, right?
Yeah,